Good afternoon and welcome to our CFE Media webcast, Industrial Internet of Things, Part 2 for 2016, Information Management for IIoT. I'm Bob Vavra, Content Manager for Plant Engineering, and I'm very happy to join you today. We're really pleased to have our presenter today speak with us on this topic. I don't think there's anybody doing a better job on explaining the Industrial Internet of Things than ARC Advisory Group. And Sal Spada is the part of the discrete automation team at ARC. His responsibilities include studies in the worldwide CNC, North American general motion control, and servo drive markets. He has more than 15 years of direct experience in motion control systems as a software developer, project manager, and product marketing manager. In the area of CNC, his concentration has been implementing high-speed contouring algorithms and vertical milling applications for 5-axis machine geometrics. Sal's been with ARC since 1997. He holds both a BS and an MS in electrical engineering from the University of Massachusetts with a concentration in adaptive control system. He also holds an MBA from Babson College. Sal, thanks so much for joining us this afternoon, and welcome to today's webcast.
Okay, thank you very much, Bob, for the introduction, and I really appreciate the opportunity here to talk about the industrial IoT that ARC has been covering for several years now. So what I'd like to do is really talk about the smart connected machines within the context of the industrial IoT, and that's where we're going to kind of bring together a number of examples that span from the mining industry all the way to the discrete manufacturing industries. So with that, I'm going to begin and kind of give you the sense of how big the IoT framework is in terms of the Internet of Things. As we all know it today, the Internet of Things spans from the consumer applications, whether it's automotive, home, the power generation industries, etc. So, and also it includes the manufacturing industry. So when we talk about the industrial Internet of Things, we're very much specifically talking about manufacturing, whether it's the process industries or the discrete manufacturing and even the hybrid industries. So within that context, when I talk about particularly in discrete manufacturing, I wanted to give you a little bit of a backdrop in terms of why there might be some impetus for many of the machine builders today to think about connecting their machines, bringing it to the Internet. If you look here in this analysis, what we've done is looked at the machine building industry relative to other industries and look at the profitability. And what you see is machine builders are probably one of the least profitable industries, relative to medical, drug manufacturers, aerospace, and defense. And so the challenge is, for machine builders, there's always the margins are constantly being driven down. The prices as a result of their customers are always declining. So there's a tremendous amount of challenges that the machine builders face today to try to operate their business at a profitable levels. And so we look at the industrial Internet of Things as an opportunity to really look at other streams of revenue that machine builders can leverage. And the industrial IoT can bring these can allow machine builders to really consider alternative revenue streams. Whether it's from services or providing equipment replacement or even, services in terms of traditional services in terms of repair and maintenance, but also other services, whether support in terms of utilization, improving utilization of machinery, or increasing the availability through whether it's predictive maintenance programs that improve the uptime of machinery. So we look at the industrial IoT as yet again another opportunity for machine builders to improve their business performance as well as their machine performance. From a manufacturer's perspective, you have to think about it. Industrial IoT is pretty much the next generation of manufacturing, because manufacturers try to encapsulate it in this short paragraph here. But the idea is manufacturers are going to look at the industrial IoT as a way of increasing the amount of data capture from their plants, from their operations, improve upon their operations. Because today, with the industrial IoT, we're talking about cloud computing. We're talking about new types of analytics that are being driven in the cloud to provide more capabilities for reasoning and for identifying problems in your operations. And so this is enhancing the human element of many manufacturing operations today. So with the industrial Internet of Things, we look at a framework, really, where underlying all of these entities, or underlying the entire framework of the industrial Internet of Things, we look at the first level, which is the sensors and even people who are considered sensors in these industrial Internet of Things, because we're bringing information from these, whether it's intelligent devices, intelligent sensors, and bringing it through some sort of data acquisition or connecting these sensors to applications which might be housed which may be situated in the cloud, for where they're doing analysis or aggregation of all the data and doing relatively sophisticated analysis. But the architecture also supports not only traditional plants where you have machines sitting on the floor, but you have to think about mobility, mobile machinery, whether it's mining equipment that's large haulage trucks, or mining equipment that's down in the mine shafts, as well as mobile equipment in the warehousing and distribution centers. All of these types of applications have to be considered as part of the entire framework of the industrial Internet of Things. The other aspect of industrial IoT is that we're talking about an ecosystem. It's not just about connecting equipment, but it's also about creating an ecosystem that connects many different suppliers to your operations. So, but at the first stage, we have to think about how do we connect through this digital umbilical cord from your equipment throughout the entire ecosystem. And one of the biggest concerns today, and one of the biggest issues that people face, is a secure connection, a safe connection that will allow your plant, your equipment, to move data throughout this ecosystem in a secure fashion so that it isn't compromised. And that's one of the biggest challenges that is being addressed today within the industrial IoT. And so once we've secured that connection, once we've created this digital umbilical cord, we're talking about creating an opportunity for asset providers, asset manufacturers that can provide better services, that it can improve your uptime of your equipment and reduce any kind of disruptions in your operations. And a lot of times, one good example of this might be in the case of if you think about an ecosystem here where machine tools are being operated in your plant, and a tooling operator, for example, will be collecting data from your machinery and providing more statistical analysis, which will provide you better information on how to operate your machines with their tooling. So that is part of an ecosystem that we want to think about. So they can start to look at, whether or not that tooling needs to be replaced more frequently. Maybe provide you with better information on how to operate that machine with that particular tooling because of the materials. But there are many more examples of that nature. But you have to think of it as an ecosystem. So the other aspect is we have to also think about availability. There's two aspects of industrial IoT we'll be talking about here today is improving availability of machinery as well as improving the utilization. Today, what we've started to see is a tremendous amount of emphasis being placed particularly on improving machine availability through collecting data using the industrial IoT to provide equipment protection algorithms, or to effectively monitor the equipment remotely and provide intelligence, whether it's through data scientists or automated algorithms that allow third parties to start to ensure that your equipment doesn't go down because of false trips or false signals that really can shut down your equipment erroneously. And we see this, in turbine machinery applications, oil drilling applications and things of that nature, where many times machinery will shut down erroneously, where in fact it should have stayed up and running. There also is a tremendous amount of interest in incorporating adaptive control algorithms, where you can start to modify the equipment parameters, operational parameters, to allow it to work through variations in particular materials that may be flowing through the equipment, whether it's in a pumping application or even in a machine tool application. The third item, which we see a tremendous amount of effort going, is predictive condition monitoring. And this is pretty much the killer app for industrial IoT today. But that is where many companies are focusing on predictive maintenance and replacing traditional scheduled maintenance with predictive maintenance. And so predictive condition monitoring is one of the biggest areas of interest going on in this market today. Now, the other aspect from the manufacturer's perspective, we want to think about increasing machine utilization. For the most part, we believe that a tremendous amount of the equipment in the market is heavily underutilized. A lot of manufacturers have an excess of capital equipment in their manufacturing operations, and they effectively could do with less. So what we want to think about is the industrial Internet of Things is providing intelligence, providing visibility to allow manufacturers to improve their machine production output through better utilization of their labor as well as their equipment, because labor is also an important component of the manufacturing operations today. So through the industrial IoT, we have seen already that companies are identifying whether it's a machine that isn't operating properly, or it's inefficient, or they're identifying operator, the way that the operator actually is performing at the machine, whether it's they're taking too much time to set up a piece of equipment, or whether they're setting up the equipment at the inappropriate times of the day. So that's a critical part of this industrial IoT, is creating that visibility. And then the other element, which is now being investigated by a tremendous amount of companies in the PLM space, is closing the loop with product design. So that is as more information is gathered from the machinery, we're not only closing the loop with improving the performance of the machine, but also closing the loop with the actual design of the product and potentially the design of the machinery itself. So machinery operators are actually gathering data to improve the next generation of their own equipment. So we see a lot of activity, a lot of areas where industrial IoT is going to make a tremendous amount of difference. Now, some of the early adopters of industrial IoT, and it may not have been even called that in the early days, but companies in the mobile equipment industry such as Caterpillar, Komatsu, and Joy Global Mining, for example, they have already developed their own ecosystem, effectively, for improving the use of their equipment in these mobile applications out in remote locations, because there's been a tremendous amount of demand for improving the operation of these pieces of heavy equipment. And I think a company like Komatsu, which if you see in the diagram below, really demonstrates the whole idea of closing the loop on the design of their machine, creating an ecosystem where they can maintain the uptime and the operations on their of their equipment within the within the mining operation that they're situated. So, for the most part, we believe that this whole mobile equipment is really a revolution that has taken place over the last 5 or 8 years within the mining industry, and a lot of it has to do with they've incorporated, in the case of Caterpillar and once again Komatsu, it's not only connecting their equipment through these remote remote mobile devices, but also the fact that they've incorporated autonomy in the equipment. These are the first generation of self-driving cars, self-navigating vehicles that are out in the field, and they're able to direct themselves without any kind of drivers. And one of the impetuses behind this was the fact that this industry is typically located in very remote locations. The cost of a driver in these locations is very expensive, and the idea of incorporating autonomy was really driven by some of these business issues that they were facing. But one of the things you have to recognize is these systems are closed, and one of the biggest complaints when you talk to mining industry operators is that what you have is fundamentally a system of connected devices, but it's completely closed. So the idea of having a heterogeneous group of operators in the same ecosystem is not really practical. So, for example, if Komatsu and Caterpillar both had mining equipment within one facility, they would be both using their own type of industrial Internet of Things ecosystem, and they would never be merged together. And that's one of the biggest challenges going on in that particular industry today, is to look at ways of integrating or creating standards that would allow these two bodies to work together. So, to further on the discussion of the industrial Internet of Things, quite a bit of it is about knowledge discovery, or machine learning, I think is the common term that's used in this particular market. What I wanted to talk about here is that there's a tremendous amount of analytical tools that are being developed today to create knowledge, and that is the knowledge created through vast amounts of data. In fact, if you think about some of the things that Google has said, Google, for example, has stated, we don't necessarily have the best analytics. We just have more data. And so what's driving the market today in terms of knowledge discovery is the fact that companies want to create more data sets, create larger volumes of data to utilize these analytics and provide more knowledge about their operations. So, and the real advantage is that we're trying to shorten times, to reduce times to identify problems in production, particularly in production operations, so that we can start up much more rapidly on new product development or make faster corrective actions, and basically ensure that we have a faster time to market. So what manufacturers need to do today is to think about creating an environment where you're instilling, basically everything is data-driven. Look about collecting more and more data, because now we have the potential to analyze this data in large computing systems in the cloud, for example. And so we also want to decouple the operator. If you think about it, we want to decouple the operator from being an integral part of that whole operation, because a lot of times today the knowledge base that the operator has is very important in running the operations. And as we all know, the labor force is the skilled labor force is declining. That knowledge that's been developed over years is moving out of the industry, and now we want to somehow substitute that operator's knowledge with data-driven systems. Now here's an example of, for example, a data-driven application where data is being collected from the devices on the manufacturing floor or the mobile devices. It really doesn't matter where the systems are, but these are your production environments, and the data streams are moving into the cloud where there's large repositories to store this data, and then we have analytics that is being run on the cloud data. Analytics is really just another word for statistical analysis, and to combine the analytics, what we need to combine with the analytics is somebody called the data scientist, and the data scientist is filling in the gap for analyzing some of the results from these analytic engines. And through the combination of analytics and data scientists, we're creating new production rules and moving these production rules closer to the operations so that now we can have much faster reaction times to events that are occurring on the production floor today. So these are called complex event processing engines that are being moved on the production floor, that are being driven by the rules that are created by long-term analysis up in the cloud, the analytics, and the utilization of the data scientists. Some of these techniques have already been utilized quite extensively, for example, in the stock market, where these complex event processing systems have already been utilized for the last decade or so to make trading, to improve trading algorithms. Now, our belief is that the analytics and the knowledge that will be created through analytics will improve the operations of the manufacturing enterprise. And today, we believe that the manufacturing intelligence that's available today has already hit a plateau. Okay, there's another evolution that's going to take place with this increased knowledge that will allow us to achieve higher levels of performance once you move your manufacturing operation to a data-driven environment. Now we'd like to look at a business case. If we look at a business case for industrial IoT in the metalworking industry, for example. We've done some analysis over the years. We've been collecting data on the machine tool business for, since I've been ARC for almost 19 years. And our information on this particular business is pretty solid. And what we're looking at here is the machine tool industry, which is comprised of vertical cutting mills, laser, horizontal machinery, EDM machines, and water jet cutting, for example. So we've looked at this business, and today we believe that this market has about $352 billion worth of machinery installed, and that amounts to about 2.8 to 3 million machines that are installed in the machine globally. And so one of the challenges is we believe there may actually be too many machines in the market today, and people are acquiring machines unnecessarily. So we've gone through a simple analysis, and if anybody was interested, I can certainly provide the later on the details of how this was developed, but I want to just give you the high-level results. And first, what we did was looked at the overall production value that is generated as a result of utilizing these machines, and we're looking at $453 billion worth of production output from these 2.8 million machines. Now let's assume that the average manufacturer is producing has a gross margin of around 22%. That means the operating cost here is roughly $353 billion for these machines. So what we did was we backed that out and looked at assume some basic some average cost of operating the machines. For example, $65 an hour if you look in the lower left hand of the screen to operate the machine. The labor cost that was on top of that was another $25 an hour, and the weighted average cost of capital was around 11%. And as a result, when you go through all the calculations, you realize that the machine utilization is around 45%. And I've compared this to other analysts in the market who have taken a different approach, and we all come up with roughly the same number, or even others have come up with even lower utilization. But this is based on our internal analysis. So what it suggests is that companies are operating either blindly or they just don't know how to improve the utilization of their operations. And we feel strongly that this is a very strong case for connecting your machines, using smart connected machines in this industrial Internet of Things environment to improve your costs, to improve your utilization. But some of the scenarios that we've come up with that might be affecting the utilization is there are many specialized machines on these production floors that simply have limited use. There are other situations where the setup and the process setup is limiting utilization. There may be just simply too much capacity, as I mentioned before, in the market where there's just too many machines that are being purchased, and there's a lot of hidden equipment out there. There's also the possibility in this market that there's too much variations in tooling or the materials that are being purchased, resulting in a lot of waste on the production floor. And then the labor pool is one of the other factors where, in this particular industry, you have you require really a skilled labor pool to operate these machines in a consistent fashion. And as we have a high turnover in labor, or the skilled workers are exiting the market, we have a difficulty in setting up this equipment and providing good quality output. The other aspect might be this batch order, much higher number of batches being run on these machines as we go toward fewer smaller lots and more production setups that need to be done. So this is really where IoT is a business opportunity to improve these machines. And it's a business opportunity for the machine tool builders to support their equipment in the field. We believe that the equipment operators could very well be an integral part of solving this problem by providing the connection to the machines, providing possibly the data scientists, the cloud repository, and all of the infrastructure that would be necessary for the manufacturers to export their data to the third parties. But overall, we believe that the opportunity for the machine builders would be allow them to reduce their operating time for a particular workpiece that's being cut on the machine, because they'll have recommendations. They'll have better visibility into not only a single manufacturer's operation, but many manufacturers' operations, where they can start to make recommendations across different industries. So we find there's many benefits here you can read through, but the other part is, which you have to think about, and I like to stress the whole idea of closing the loop. You can close the loop also with the machine builder by improving, once again, the machine builder's product, as well as the individual product being manufactured on the machine itself. And we can incorporate the intelligence that we're learning into some of these CAM systems, some of these PLM systems, to create knowledge that can be utilized over and over again to improve operations. Now, what we're seeing in the market today is automation suppliers are taking a very integral role in supporting the manufacturing community as providing the infrastructure. So companies like Rockwell Automation, for example, have built up their business, or started to build up their business with the future goal of providing an infrastructure for machine builders to provide these services. And if you look, most recently I did some research on some of the patents that were being developed by Rockwell, and it has here's this recent patent 2014-0047-107, and this was published in relatively recently in 2014, where they have put together a vision for a complete cloud infrastructure for remote monitoring of equipment and providing a secure connection to machinery. Now, of course, this is really a service or an infrastructure they're going to be providing their customers so that they can build out the services that they need. And one of the other aspects of it is they have a vision, which, if you look very closely at the patent, that they're going to be supporting not only the individual pieces of equipment, but also providing an infrastructure for remotely hosting a software that is traditionally located on the plant floor. So we're looking at remote software software that's located in the cloud, and providing operations that can be easily managed without having to support all of the updates that are traditionally required on the manufacturing software. So this is a real visionary concept, and I don't think it's unique, but it certainly typifies what I believe is going on in the industry today in terms of providing infrastructure. The the other aspect of it is we're looking at the capabilities being provided here with this infrastructure, where it's also talking about security, providing a secure infrastructure where data is being collected on the plant floor, but has to be pushed up into the cloud in a secure fashion. And this is one of the biggest, as I mentioned before, one of the biggest barriers to the whole industrial IoT is providing that level of security to the manufacturers, that their data can be collected on the manufacturing floor and pushed up to the cloud for further analysis through analytics. And in some cases, what we're seeing here is in between the cloud and the individual pieces of equipment, we have these gateways that are providing local analytics. And some companies call it edge computing. Others may call it fog computing. But effectively what we're looking at is some of the analytics being pushed down closer to the equipment and then further moving that information back up into the cloud. In fact, if you happen to have seen a release today that IBM and Cisco have created a partnership where IBM's Watson technology is moving on to the Cisco edge devices and providing that edge analytics. So it's a very, every day we hear something new, but this is very timely in this particular discussion. Okay. And one of the areas that Rockwell actually has been providing services for close to 3 or 4 years, and that's in their motor control centers, where they provide these remote connections to their drive technology located in their customers' plants. They not only pull data and put it into the cloud, which is the Microsoft Azure cloud, but they also provide the data scientist to interpret the analysis, to interpret the data that's being analyzed. And that's a very critical component, because a lot of manufacturers today just simply don't have the expertise in-house to analyze the data. And so through monthly service agreements, these secure connections are being monitored remotely at some large service center, providing support to manufacturers in terms of when they should be replacing pieces of equipment or shutting down pieces of equipment. But it's already been in place and proven to be quite effective. The other company that I've been looking at too, in terms of the overall implementation of the infrastructure required for the industrial IoT, is certainly Siemens with their analytics offering. They've been effectively using using the digitalization strategy to push out the use of digital services to their customers. And they've been doing this across some of their rail business, some of the medical business, and also the industrial business. And most recently they reported in their financials, if you can find this as well, but over 600 million euros in digital services were pushed out into 2015. And that was 15% year-over-year growth in their particular services. So what we're seeing here is not only machine builders can profit from this, but also automation suppliers can look at this as a new revenue stream for their businesses as well, if they can provide the infrastructure. Because machine builders aren't necessarily going to be able to provide this infrastructure. So when we look at Siemens product lines, we're looking at something called Synalytics, which is the way they've branded their platform for providing analytics as a service. And this is the way they've branded their own service offering for, like I said, analytics. But then they've also provided something called MindSphere, and MindSphere is where a machine builder can build applications on top of the Synalytics platform to develop their own analytics that is specifically developed for their equipment, whether it's the mobile machinery market, or whether it's cranes, or whether it's elevators. And here, this is where the machine builder would incorporate their knowledge, their intelligence to develop the knowledge systems that will develop more and more capabilities over time to improve the operations of their equipment in the customer's plants. So those are just some examples of industrial automation suppliers today who are actually supporting this whole movement toward industrial IoT, and certainly there are others that are moving in this direction, whether it's GE and Beckhoff and et cetera. But these are the most ones that I closely watch because of my focus on the discrete manufacturing space. So one of the things I wanted to wrap up with was really what are some of the challenges that we're facing with moving, at this point in the industrial IoT. Certainly one of the biggest challenges that we all hear about is this issue of cybersecurity. How secure is the connection to your plant equipment? And, for the most part, what's happened today is many companies have basically a unidirectional connection to their plant for collecting data. They'll be able to pull data out, but they're not really allowing third parties to come in and modify the operation of the machinery because they're concerned about cybersecurity and whether or not the machines can get hacked into or the operations can get hacked. The other aspect, and this goes back to standardization, technology standardization. I gave you the example of the mining equipment manufacturers, the mobile equipment manufacturers. Today, Komatsu or Caterpillar can't have really separate connections to their equipment that are all proprietary. But we want to think about using a common industry connection for that particular industry. So a mining operator can have Komatsu equipment, can have Caterpillar equipment, and can be able to monitor both on one type of in one system. The third item is who owns the data. And I may have talked about this briefly, which was the fact that we have data coming from manufacturers, whether it's in the automotive industry, and you might have Ford, Chrysler, BMW, et cetera, all pushing data into the cloud. And who has access to all of that data? Can a machine builder look across all these different companies and start to make the connections in terms of improving performance, or does it really need to be the ownership of those particular manufacturers? And that'll be a constant debate over time, because ideally you'd like to create best practices across industries, but it will be a debate for quite some time on who owns the data to create those best practices. And then finally, the increasing complexity we see going on. More and more devices are connected, more information is being brought up to the cloud, and we have a tremendous amount of complexity in how to integrate all of these sensors and mobile devices into a complete system. And that is still evolving today with the evolution of things like gateways and things of that nature. But that will be one of the biggest, that will be yet again another big challenges. And these are the 4 items that I think that need to be addressed before we see a rapid explosion of the industrial Internet of Things. But I would recommend, if you want to stay informed, we have a blog on ARC's website, which is the Industrial IoT 4.0 Viewpoints. And you're certainly welcome to follow it or even contribute to that particular blog. We've been operating this for about 2 years now, and we've got a tremendous amount of following. But with that, I thank you very much for this opportunity to talk about the industrial Internet of Things.
Well, a great presentation, Sal. Thank you so much. And we will be getting to some of our attendee questions in just a moment. Right now, we want to hear from two more of today's webcast sponsors, Red Lion and Rital. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied Internet speed. Please stay tuned after the videos for our live Q&A session.
For over 40 years, customers around the world have trusted Red Lion Controls to help connect, monitor, and control industrial operations. Today, we are helping these organizations embrace the industrial Internet of Things to do more than ever before. Building on our strong history of industrial innovation and excellence in protocol conversion, we are expanding their ability to see more and to do more, regardless of location. And we are providing more options than ever to bring it all together to drive efficiency. With automation and networking products designed to interconnect disparate devices from virtually any manufacturer over virtually any kind of network, Red Lion will help you get IIoT ready by unlocking the value of data hidden in your enterprise. Visit www.redlion.net to learn more today.
The Friedhelm-Loh group of companies works together to simplify and unite the design and manufacturing process, a major portion of Industry 4.0. ePlan's computer-aided engineering environment enables designers to pull in an actuator along with its manufacturer-provided attributes, auto-populating the electrical and mechanical design with parts and creating a bill of materials that interacts with supply chain and inventory software. Component interfaces within the enclosure can then be simulated to ensure proper interaction and operation, and the design can be thermally simulated for excessive heat loads between components and within the enclosure, ensuring that finished products will function exactly as intended upon installation. Once the design is completed, a modular Rital enclosure is selected for its ease in hardware and cooling systems installation. Adding custom holes and installing enclosure electronics is automated thanks to Kiesling's panel cutting and wiring machines. This interconnection simplifies the original design and enables automatic updating of the complete design if the first step ever changes. From wiring diagrams to custom holes, automatic updates tremendously decrease design iteration time.
If you've got any questions for Sal today, please type those into the Ask a Question box on your screen, and we'll be having this presentation also available for on-demand viewing. We'll post the archive on the Plant Engineering website, and we'll send you an email message with a link connecting directly to it and to related resources after it's ready. As a reminder, to take the Learning Unit exam, use the Learning Unit Exam tab option at the top of your screen. The exam will open in a new browser window, and you can complete the exam after the webcast. However, the link will break when the webcast signs off. And the exam will be posted on the Plant Engineering website with the on-demand version of this webcast. We've got a number of questions and a short amount of time to get to them, Sal, but let's start with where to find the value of IIoT. Is it at the sensor level? Is it in the data software? Where do you see the value in the near term for IIoT?
Well, that's a great question because we see a lot of activity, and as I mentioned just recently that, for example, the recent partnership with Cisco and IBM, for example, demonstrates where the data acquisition or the gateway devices are being increase with higher value by putting analytics right at in the gateway device. So we're moving some of the value that was value generation that was in the cloud from the analytics and moving it closer and closer to the equipment. Now, that being said, there's no reason to believe that we couldn't start to see an evolution of moving some of this analytics into the sensors. I mean, as you know, there's millions and millions of sensors being sold every year, and but the challenge is they don't have necessarily the computing power to do any type of analytics. So I think in the long run, what I don't believe that you'll see the sensors necessarily increase their compute power, because it would drive the cost up too high for many of the manufacturers. I think we'll start to see more and more value creation being placed on the gateways, the edge devices, which are part of the whole networking infrastructure, where we'll see a lot more value being built up there.
And we're going to see some value at the human level in all of this, the ability to take all of that data and all of that value that's being created and actually put it into some action.
Absolutely, and that's a third element where the human element comes in. If you want to talk about that, that's really where we have the data scientists, I think, interpreting some of this data, and there's a lot of value being created there, because it goes back to one of the diagrams I showed you earlier, which was the data scientists are an integral part of this whole part of the analytics. And companies, manufacturers won't necessarily be able to bring data scientists into their operations, because it won't necessarily be able to afford it. So we're starting to see a opportunity for many machine builders or equipment suppliers to provide their own data scientists and to support the manufacturers. And
there's going to be some third-party companies. Yeah, there's some third-party companies that are going to be involved in that process as well. Absolutely.
There'll be a whole, it's part of the whole IoT ecosystem that will be developed in this sphere.
Very good. Well, we're right near the top of the hour here, and we want to be sensitive to everyone's time today and thank everybody for jumping on the webcast.